Well, when we usually refer to the things that we learn at school, most of people usually says that we never use that in life, and the most attacked subject in all this is without doubt math, and it has been target of critics and puns like, oh yeah, I'm going to the store and I'm going to ask for p per square radius of bread. Like, it's a subject that is quite critical around all history because of how complex it is, and because it is complex, people usually think, well, outside of school, you never usually use it, and that is totally fake. So that is the reason why we are doing this project.
Okay, what we accomplish and learn about the uses of functions in our daily life to deny these rumors. In this case, we represent this with emissions of CO2 per capita in tons, with Y, with Y representing this value, while X being the amount of people in the world.
Okay, so the materials and methods. The materials and methods we use were actually the page of Desmos to make the graphs, as well as Excel in order to make the tables, and also more graphs in order to get the different type of functions. The types of functions we use, or the methods per se, we could say were the verbal, tabular, graphic, or and symbolic functions.
Okay, so what we determine that the graph will always increase because since history the amount of people in the world has been always bigger than zero. It is rarely that it can hit to the number zero. The variable will never reach the negative number. Okay, anything related to the CO2 in general is quite complex, seeing the consequences on the human body and the environment. Passing through its cycle, its a natural regulation, and finally, until the way of determining the amount of CO2 existing or emitted in a certain amount of time. This sounds quite complex and is some way hard to achieve, but it can be summarized in y equal 4.79x and the x can be found easily in every day of the year. So y is also easy to get.
So now the next is the figures. In this case, we can see the charts per se of the actual figures over here. As we can see, we have different functions over here representing x and the y, and getting the domain and range from each line. In this case, this type of function is the graph and tabular.
Well,
Also,
as mentioned before by my partner Avejan, the CO2 topics in general, all of the CO2 topics are quite complex, and well, it sounds like hard, but a simple and basic function that most of us learn as kids or at junior high make the explanation of the CO2 surprisingly quite simple. And in fact, this proves that it's completely fake, the rumor that the things that you learned at school are completely useless for life. That it's lying. That is a lie. It's not true. And this is a confirmation of this because people historically try to summarize and make simple things out of numbers using verbal expressions, using expressing orally, but they are also forgetting that some things can't be explained at all, or can be explained in an easy way with words. And the numbers are a very good explanation for this. It can simplify some things, even though it's some like surprising to most of the population, but it can make things quite simple. And this is the case, like a simple basic function can resume the total CO2 emissions per capita in tons. And it is quite a hard thing to explain at all when we refer verbally with only the variables to express them without numbers is it's quite hard. So this is completely surprising for me, for my team also, that the math can also explain some things that most of us think that we can explain with only words. So this proves that school learnings are useful, very, very useful, and that you cannot believe anything at all. You need to investigate, you need to be sure, you need to have a confirmation, and this kind of project that we make with functions, it's a very quite good confirmation of this. Thanks.